is some steps for solving linear equations. Now, it's kind of arbitrary to just say it's always step 1, always step 2, always step 3, because you might do things in different orders. But just to be consistent with your notes and the textbook that we wrote this lesson from, while I work the problems, I'm going to be writing S1, S2, S3 down the left-hand side, and that means this, step 1, step 2, step 3. And I'm not really going to read this or have you read it. We'll sort of do it as we go. But there are 4 steps total with an optional 5th step to check your work. This part of your notes, I think that's the bottom left, tips for making solving easier. This tip is for fractions, which I'll talk about when we get to the fraction problem. And this tip is for decimals, which I'll talk about when we get to that problem as well. So don't worry too much that I'm skipping over them. We'll talk about it. So here's our first problem. Okay, this no fractions, no decimals, all integers. Read the first step on your notes with your eyeballs so it's in your brain, because that's the first step I'm going to do. The first step says to distribute to get rid of parentheses, right? Which side of this equation has the distributive property or the parentheses? The right-hand side. And it's got a negative out front. There's no number, but we always understand when no number is written that it's really a 1. And so if we're following step 1 to distribute, it's the -1 that gets distributed in there. And I'm just going to rewrite everything right below it, having already distributed that -1. And by far the most common mistake when distributing is forgetting to distribute to the second term. People remember the -6w, fine, but forget that the -1 also has to go to the +7. And so we get the -7 there. And then read step 2 in your brain with your eyeballs. It says to combine like terms on both sides, right? The left side, there's nothing to combine there. I have a term with a w and a term without. So those are not like terms. But what can I combine on the right-hand side? Over here. The 9 and the 7. They're both negative. So that makes a -16 minus 6w on the right and -12 minus 5w on the left. And now read step 3. Step 3 is that part that we call a 2-step equation. Okay, you have variables on both sides. You have constants on both sides. Your goal is to get all the variables on one and all the constants on the opposite. And there's only 2 ways to do it, and it does not matter which one you choose. What I'm going to do is add 5w to both sides, which moves the variables to the right, which means I need to take the constants on the right and move them to the left. And for this problem, that means moving -16 over by doing the opposite, which is add. So on that right-hand side, the 16s cancel out, and -6w plus 5w is a -w. And then on the left, the w's cancel, and -12 plus 16 here gives me 4. And if you moved your w's to the left, instead of like me moving it to the right, you'd be done right now, because your answer should already say w equals blah, blah, blah. W equals -4, right? But I just have one more step to do, and then I'll get that same answer. That's the last step, which tells you to multiply or divide both sides by the coefficient to solve. And in this case, my coefficient is a -1. So I divide both sides by that. So -4 equals w. And I'm done with that problem. Okay. So pretty standard 2-step equation with the addition of distributive property. Questions about this problem? Okay, you do that problem. It's kind of the same, just an additional distributive. If you do not have 51, check your numbers with mine up here and see if you can figure out where you went wrong. The only real mistakes I've seen all day are just simple math mistakes. Multiplying wrong, adding wrong, but most people have understood the process pretty well. Are there any questions about that problem? Okay. This corresponds with your homework numbers 7, 9, and 11. So I wrote that up there so you could, because your homework's kind of long, and I wanted to compartmentalize the problems for you a little bit. And so those are the 3 that are like this on your homework. After this, we're doing the decimal kind, and then we have a fraction kind. Right? So no questions on that one, right? We're good. We're good to do decimals. So here's the decimal one. And what I'm going to show you is a tip for people who don't like working with decimals. They'd much rather work with integers. You don't ever have to do this if you don't want to. If you're completely fine with decimals, I'm fine with decimals, especially if I have a calculator. It pretty much doesn't bother me. But this is just a helpful tip. The first thing I'm going to do, though, is the same as the other one, and do the distributive to get rid of the parentheses. So step 1, distribute here and here, and everything else I'm just going to rewrite and bring it down. And here's your tip for converting the decimals to integers. Every single decimal here happens to have only one decimal place. Okay? If you multiply, do you remember the number you multiply by to move decimals? 10, right? And so if there's one decimal place, if you multiply everything by 10, that decimal will move over one spot. If one of those numbers had 2 decimal places, like instead of 7.9, maybe this was 7.94, it would multiply by 2 tens, which is what? What's 100? It's 100, right? And if it was 3 decimal places, you would multiply by 1,000, etc. All we have to do in this problem, though, is the 110. And so before we get to the rest of the steps, we're just going to do that. Multiply both sides by 10. So I'm going to just put that in red here and here without rewriting everything with that. And the reason why I've set it up as a distributive is because, again, in order to keep the equation balanced, the thing that you're going to multiply by has to be done to every single term on both sides to keep the equation in balance. So now I've got 79 minus 26w equals 15w minus 91 minus 21w. And then after that, it's just like the last problem. So go ahead and finish it out for a few moments on your paper. you should have 17 halves or 8.5. So if you've gone rogue somewhere, check your numbers with mine and see if you can catch your mistake. Because a lot of your processes were correct, but your computations or your math, like your adding, multiply, subtracting, dividing, were off. So take a minute and match yours up if you need to. Is anybody stuck and they just can't figure it out where they went wrong? Okay, so no questions on that one. This is like homework numbers, let me see. Of course, these would probably be the easiest ones to figure out just by, because they're the only ones with decimals, but homework numbers 23 and 25. Once you get that. Okay, so the last problem is the one with the fractions. And I'm going to show you some sort of simpler problems to build up your memory about what we do when there's fractions and equations. And you don't have to write this down. I kind of just want you to listen. Let's consider the q over 6 for just a second. Let's say I didn't have all that other noise and I only had this. How would you solve? You'd multiply both sides by 6. And you'd cancel the 6's out, and you do 2 times 6 on the right-hand side. What about if you had a different number, right? If this wasn't just a 1q up here, but it was a, oh no, I don't want to say that. So you have q over 6 equals 2, you multiply both sides by 6. And if you had q over 8 equals 2, what would you multiply both sides by? 8, right? The problem here is that we have a 6 and an 8 in a denominator. So even if I were to multiply everything by 6, the 6 would cancel here. I'd multiply all these things by 6. It wouldn't take care of this 8 denominator, right? 6 doesn't cancel out 8. And vice versa, if I multiplied everything by 8, the 8 would get canceled, but that wouldn't do me any good with the 6. And our goal here is to get rid of the denominators and make everything integers. It's a process we call clearing the denominators. And if we can get everything into integer form, it makes our math easier. Fractions will increase our likelihood of making a mistake. It's not impossible, but it just makes it harder. And so any suggestions how we might be able to get rid of the 6 and the 8 at the same time? Least common denominator, right? Raise your hand if you remember what that means, the least common denominator. Yeah. The least common denominator is a number that I can multiply all the way through that would simplify the 6 out, it would cancel it out, and cancel out the 8. But generally, when I ask students, okay, what number do you think would cancel out 6 and 8? Students tell me 2. Well, here's a problem with 2. 2 is not canceling out anything. See if you can follow my vocabulary words on this. 2 is a factor of 6 and 8, meaning 2 goes into it. What we need is a multiple of 6 and 8. It's bigger than the 6 and the 8. That 6 and 8 both go into the smallest number that would cancel both of them out. It's not 2 or 3 or 4. It's bigger than 6 and 8. What do you think? 18? 18 works for the 6, because if I had an 18 up here, 18 over 6 would reduce to 3, but 8 doesn't work. That doesn't go in evenly. 24. Is that what you're going to say? Is that what you're going to say? 24? 24 absolutely works. So let's look at what happens when we multiply everything by 24. So make a note to yourself somewhere, and this is over here, right here. If you have fractions in your equation, multiply the entire thing by the LCD, the least common denominator, to eliminate the fractions before starting to solve, okay? Or sometimes you might hear least common multiple. And so in this case, that's 24. So I'm going to start by multiply both sides by LCM, which is 24. So it's a distributive property again. Distribute, distribute, distribute. When I go to distribute the 24 to the q over 6, you might be feeling like, how is that canceling out the denominator? Because when I go to multiply fractions, I know that I multiply across the top and across the bottom, which gives me 24q over 6. And, well, there's still a denominator-ish, right? What is 24 divided by 6? 4. That simplifies completely to an integer. And that is how the denominator gets cleared. Okay, it's gone. And then I continue distributing on the left-hand side. 24 times positive 1, 24 times negative 3q. On the right-hand side, I distribute 24. 24 times 2 is 48. 24 times negative 4q is a negative 96q. And then 24 times that q over 8. Multiplying fractions again, across the top, across the bottom. This was really 24 over 1. 24 in q is 24q. And then 1 times 8 on the bottom is 8. And again, what is 24 over 8 simplified to? 3. So there, no more fractions. And the rest of that problem is just like the other one, so go ahead and finish that out, and then we'll talk about it. If you got your variable on the right-hand side, like I did, at this step right here, you'd have a negative over a negative. And sometimes that trips people up because they don't remember what exactly is going on there. You can leave 24 over 25, but a negative divided by negative is a positive. So if you leave it negative 24, negative 25, I will circle it for not being simplified. I'll circle it and give you partial credit. And then as I was walking around, some people, again, they had different methods, got to the same answer. That is not a problem. That's fine. Okay? Your homework is kind of long, and I have modified it for you a bit. I really wanted you to just focus on certain problems. I think I modified it down to 2 of the plain distributive ones with already integers, 2 with decimals, 2 with fractions. But just in case you wanted the extra practice and you want to do the rest of the problems on the answer key, I have the answers for those, but I only have the solutions for the one I required you to do. So here are the modified problems that I wanted you to omit.